Welcome to the Better Buildings, Better Society podcast. Twice a month, we interview interesting individuals and get insight into what they think makes building better members of society. Subscribe to our podcast and share with your friends. Hi, I'm Stephen Forster, founder and principal of DMA Engineering. My passion lies in the built environment and in the mechanical systems that keep buildings running at their optimum efficiency, while at the same time provide the best possible health and comfort to their occupants. In this way, DMA is absolutely committed to making buildings better members of society. This podcast focuses on energy efficiency through the eyes and experience of building industry professionals. Together with my guest, I will lead all of us on an exploration of how to build better energy efficiency buildings, how to save our clients time and money, and offer practical advice for those interested in the built environment. Join me, a mechanical engineer, outdoor enthusiast, and green advocate as I interview guests with leading edge ideas for creating better buildings and a better society. Hello again. I'm Stephen Forster, principal of DMA Engineering. Thanks for joining us for another episode of Better Buildings, Better Society. This week we have Todd Collins, founder of AE Building System. He is an expert in providing products that help builders, architects, home and building owners create comfortable, energy efficient, and healthy environments to live, work, study, and play. We are excited to be hosting Todd and thrilled to explore more about how his industry can make buildings better members of society. With that, it is our privilege to welcome Todd to the show and learn more about what inspires him in this industry. Welcome, Todd. How you doing today?
Hey, how you been, Stephen?
Been pretty good. So yeah, just a little bit before we jumped on this, we were talking a little bit about the
Natural Building Conference?
Yeah, that conference you went down to Moab. Give us a little bit of a rundown of what that was about.
Yeah, it was about building with natural building products. So no foam, staying away from PVC, plastics, etc. A lot of homes are built out of cob, basically a straw and a fiber and mud mix. And then, of course, all natural exterior adobe finish, interior plasters are natural finishes. Beautiful homes, but in a very interesting conference for me because I haven't been exposed to a lot of that information of those materials in the past. So it was a good one. Yeah,
and I know you do a lot of work with the passive house stuff, but that's not truly what you started your professional career with. Give us a little bit of your history into the built environment.
I almost did an architectural degree for undergraduate degree, but I learned quickly that was a 5-year program. And coming from a pretty blue collar family, computer science at 4 years was where I ended up. I have an aptitude for technology and technical things, and I ended up finishing with a computer science and business undergrad, and eventually went back to school because I was going nuts writing code, and got a master's in business with focuses in marketing and entrepreneurship. Went back into technology, but always had this concept of passive solar design in the back of my head. I'd pick up a book here and there, but I did a paper on passive solar design in high school back in 85, 86. And it was the impetus for this 30 years ago. What is that? 85, 86, 35 years ago, 36 years ago. And came back to it when I started looking into it. I'd been traveling quite a bit in the sales world, and I really wanted to be the dad that was home for dinner and not the guy that came home on the weekend. And we had 2 children back in 08 and 10. I'm sorry, 08 and 10, and wanted to kind of switch careers with the concept of being an involved dad, being here, and went back to this concept of passive solar design and found Passive House and took the training and learned that there were a couple of holes that could be filled, and one of them was actually being, solid in the information related to products that help to achieve Passive House. So that's kind of how I landed where I am now.
Yeah. So a passion that you had back in high school, and a passion to be home with your children kind of led you to the world that you're in now. And that's making buildings better members of society. So that's cool, right? I mean, it's a holistic thing that kind of feeds everything that you need to have a good, healthy life.
Right, right. And interestingly enough, AE stands for architecture engineering, or Allison and Emily, my daughters. So it's a dual meaning.
See, that's awesome. Yeah, that's totally awesome. Yeah, that's great.
Yeah.
I didn't know that. Yeah, I learned something new there. So I guess that we covered, a couple of our canned questions here that we got through. So that's great. So what do you think? You went to this conference down in Moab, you learned some new stuff. And, where things are at right now, what do you think is going to be the biggest challenge you will face is, the passive house materials? And actually, we're starting to see those materials actually become the norm in some building construction. So what do you think in the next 3, 5, 10 years, if you had to do your crystal ball, what do you think is going to be the future there?
Yeah, and rather than looking at it as the challenge, rather the opportunity. I'm also a participant on the local City of Golden Planning Commission. And, I really believe that for the high performance industry to take off, that, we will make references to passive house, darn good house, zero energy, net zero, blah, 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 blah. We can go on and on and on. But, all of these sub niches are really our focus. We're all about having products or providing products that help to achieve a much better energy efficiency objective. And the opportunity really is in code and developing, municipalities pushing the code further and further and further. And code's getting better in general. But the real opportunity, and it really is about setting our future generations up, their environmental and energy future up in a positive way. We're setting them up for failure right now, and we need to do better. So in the end, code's going to make that happen. And, we could go and talk about carbon. We can talk about climate change. And we should probably, but in the end, I mean, we need to set future generations up for a much rosier picture than we are currently.
So, and I know what we're seeing with codes, and as the codes are changing and as they're becoming stricter, right? Those that have really dove into the built environment and got a really good understanding on how to build a really tight building envelope and how that envelope needs to breathe with proper ventilation and the materials and how moisture is moving through materials that we're putting into these, that's becoming more of a theme. But as we push the code, it's there's the architect, there's mechanical engineers, there's building science people. It's really starting to see that there's becoming a definite area where we're going to need somebody that's just pretty much an envelope consultant. Is that something that you see coming in the future, that it's just, you're going to have your architect that's going to do the form, right? You're going to have, engineers that are going to be doing the function, make sure that's right. But then there's that little slice that's going to be there that somebody's going to need to go through and just really focus on the envelope.
To some degree, it already exists. And I don't know how many times I've been asked to consult on projects. And because we sell products, there's a bit of a conflict of interest. I'm going to suggest they use our products and they're going to pay me for that. So I haven't really signed up to be a consultant. But that function already exists. There are facade consultants, for example, in the commercial world. So the commercial environment, most certainly, it already exists. There's already consultants that go and figure out why buildings fail, forensic science, building science, and how to fix them once they've figured out what happened to them. So this consulting function largely already exists. I believe the forensic guys will be a really important participant in that, especially in the commercial world. In the residential world, the dollars to hire a consultant aren't always there. There's always a budget. So, and there is in the commercial world as well, but the potential losses as a result of a building failure in the commercial world can be quite significant. And hiring that consultant on the front end is important, quite frankly.
So yeah, we're kind of shifting between commercial and residential there, that it makes sense in the commercial world just because of the cost. that could be
Right.
associated with it, where in the residential world, it's not as significant per se on your typical standard, 3 to 5,000 square foot residential project, right? I mean, there's the chances of an error aren't as significant as it is the commercial world.
Right. The risk is much greater in the commercial world for certain.
So it's a risk mitigation, right? Pay me now, pay me later type scenario.
Yeah, exactly.
Yeah. So how has COVID affected with your business? How did that affect it?
It's been kind of a roller coaster. At the beginning, everybody put everything on hold. Everything stopped, came to a halt because they wanted to see what was going to happen as a result of the pandemic. And then things slowly improved, I guess. Yeah, slowly improved over the course of 2020. And we've been crazy busy this year as well, 2021. As we, go into 2022, one of the biggest challenges is supply chain right now. We've got products that have lead times double what they used to be, double and sometimes triple, but generally we're running, double on our typical lead times right now. And that's a challenge. And it's also a moving target because supply chain issues have been happening spur of the moment. And we've had suppliers that all of a sudden can't get a key component to one of their products, and they're not even sure when they're going to be able to get it. So these have been pretty significant challenges, and it's a challenge across the industry. Trusses are apparently 18, 25 weeks in that range. I've heard anyway from recent clients that, if the windows are going to be X or the doors are going to be Y, so be it. We've got plenty of time. Trusses aren't going to get here for another 4 months.
Wow.
Yeah.
So I know with the materials that you represent, they're all in that passive house certified world. How do you see that becoming more adopted into the regular building industry? Not even people that are going to passive house. They really want those resilient materials, right? I mean, that's what passive house is there to do, is to build a really resilient building. How do you see that affecting current construction?
It's a design approach and an attention to detail concept that comes into the build. I see it growing. The niche is small in the center of the country, but it's growing very rapidly on the north coast, so northeast, northwest. There are municipalities that have essentially made passive house code. Or at least multifamily, not necessarily single family residential, but just we're seeing a lot more buildings going up that are meeting certification in the Northeast and Northwest. It's happening here as well, but not to the same degree of growth as you're seeing in the coast.
Yeah, I know for us, we've been on a couple of multifamily projects for municipalities, and we've suggested passive house, and it's kind of fell flat, right? I mean, they didn't really want to hear about it because they just thought it would cost more. But I did see something on LinkedIn not too long ago about a multifamily project in Seattle. And I think they said to do the passive house design, it only added like 3% overall to the cost of the cost. Did you see the same article?
Well, the real key is the attention to detail. I mean, if you can get your contractors to put a little bit extra attention to detail into it, you're 90% of the way there. When you're dealing with multifamily, it's really a surface area to volume ratio equation. So the bigger the volume, the lower the surface area ratio is. And and often, I mean, you can create undulations in the facade of a building and create lots of surface area that's unnecessary. But architects like to do that, and Golden actually requires it, which is one of those things that I fight a little bit. There's something about having design interest, and then there's performance. And every undulation or change in the building facade is an energy performance. Penalty, so to speak. So anyway, back to that concept of passive house in multifamily, or larger buildings. Passive house certification is much easier with multifamily because of that volume to surface area ratio.
Yeah, I always a couple of the architects that we know that are in the passive house area, I always keep telling them, I want to find us a 10,000 square foot house or plus that we do passive house. And they always bring up the surface area, right? It's like, well, I think we could do it with some modern architecture, but we couldn't do it with, contemporary or whatever type architecture where you can't do it, a Tuscan architecture where there's all those undulations are going to increase the surface area. Yeah.
There was a project down in South Aurora, Parker area, and I counted the number of turns in the envelope on the floor plans, and it was like 38 turns in the envelope. I'm like, oh my gosh. And you want to go high performance. That's awesome. Good luck.
Yeah. So I guess that's, back to a little bit of that form and then function theme that's got to be a little bit ironed out yet and still be in a pleasing building, right? Because buildings still have to be appeasing to the eyes.
I heard an architect that's a passive house guy actually say corners with a purpose.
Exactly. Yes.
So it's not that you can't have corners in your envelope. It doesn't have to be a shoebox, but corners with a purpose. That was a really interesting way of putting it, I thought.
Yeah, and I mean, the undulations do give you a shear wall, right? So there's some structure that gets in there. You could put in more, more material to take care of the shear wall. Or you could do an undulation to make it happen. So again, a corner with the purpose and then make it look like something. So it's always important. Yeah. So we kind of touched a little bit on this, and I'm going to mix this kind of into two things. Climate change, there's going to be climate change, there's going to be code. And then, you mentioned codes trying to take the industry in a different direction. So what's going to be the bigger driver? Is it going to be climate change? Is it going to be codes? And what's the motivation for codes to change if it's not people realizing climate change? So are they related or are they not related? What do you think's it's a little bit of the chicken or the egg, I guess. Is it somebody really being climate conscious? And is it going to be jurisdictions that are really climate conscious and want to do something about it that you think will change the code or what?
Well, you got two things. One's almost a philosophical question of human nature that we could go into for hours. Will people actually act in the benefit of others, down the road when they're not even going to be alive, in a way that actually helps to improve the current situation and the future situation? More importantly, the future situation. So that's a philosophical question almost. And there are most certainly altruistic people out there that say, hey, this is what we should do. It's the right thing to do, and we're going to do it. And it's going to cost us more, but we're going to do it anyway. And then they can justify it with, I want a more comfortable house. I want a quieter house. I want better indoor air quality. I want a house that lasts forever so I can give it to my kids and they can live in it forever. So you throw in the other benefits and you've got a really good value proposition, indoor air quality, health, that it's quiet. I've upgraded the windows in my house. I don't hear the wind howling in the winter anymore. I have a more quiet, comfortable, enjoyable place to live. So there's a number of reasons to go higher performance, whether it's passive house or some other darn good house concept. But having high performance fenestration, air tightness, etc., makes the place more quiet. So beyond the philosophical thing, I think the lion's share of the population is going to make this decision to go higher performance passive house. For example, when the code basically says, hey, you got to be zero energy, you got to be, you can't use more than you're producing on the roof, for example. Or zero energy ready. I've heard Summit County is zero energy ready now. So there's a lot of municipalities that have already pushed in this direction. They're already going there. Golden's wanting to just do a one-stepper. There's some municipalities that are doing multiple steps. So they're saying, like Boulder, anything over 7,000 square feet had to be zero energy. But now it's 6,000 square feet. It's moving lower, and anything over 3,500 is going to have to be zero energy in a year or so. I can't remember when, or 3,000. I don't know what the breaks are or the time frames are. but they're doing what's referred to as a step code. They're making incremental steps towards a much higher performance requirement. And Golden, because it's a small municipality, we just want to do it once. That's just, that way we don't have to train and retrain, and get it done once, get it, make it easy, simple, and it's already possible to go zero energy. So might as well. And that's the whole idea behind Golden's process. They want to make it as cost effective as possible.
Yeah, I think you touched on something there that I know as us as designers or providing services in somewhere like Boulder, where there is that step in the code, it makes it difficult for us to always stay on top of what it is. Just take the pain once and just say, this is what it is. This is the line. Boom. And then maybe in 5 years, you make a big change back down to say, houses that are 1,500 square feet will now be required to be net zero, right? I mean, that would be better than this incremental thing where it's changing and we're always trying to take it. So take your medicine once and get it done.
Yeah. We actually talked to Boulder. Apologies for interrupting.
No worries.
We talked to Boulder County. Ron Flax, who's kind of one of the head honchos up there. He's a great guy. He gave us some time, and we asked him, what were your lessons learned? He said we would not have had a prescriptive option. We would have gone performance 100%, and fewer steps, I think, is one of the takeaways. Fewer steps, not as many steps over time.
Right. Yeah, I think that's a big thing that can be a lesson learned. Boulder was definitely on the bleeding edge there by bringing this all about. So, good lesson learned there for people going forward, right? So that's the problem of being the first. You're going to make those mistakes, but everybody else can learn from them. So that
yeah. He suggested that the prescriptive path was difficult to commission or verify, and it required a fair amount of labor and effort on their end, and as a result, bandwidth and people. It was more costly, and because Golden's such a small municipality, we want to make sure we're doing it with tax dollars that make sense. Yeah.
So speaking of dollars, so if you had extra money on a project, how would you recommend a client use it?
And wow, that's a great question. I love it. The envelope. A lot of folks will say, "Oh yeah, I don't need to do the envelope. I can just throw some more solar and we can run our heat pump more." But when you look at the envelope and you make it more airtight and more thermally efficient, you also make it more comfortable. So, one of the things that I tell clients is, wouldn't it be nice to sit next to that big bank of windows in the middle of the winter and not have those windows suck the heat off your body and make you feel cold, and have really good windows, good fenestration? I mean, it's about comfort. It's about sitting in front of the window and reading a book and not have to wear a parka.
No, yeah. I mean, Windows is definitely one area where you're like, spend as much money as you possibly can because the comfort level is going to be so much greater with that, right? I mean, that's one thing that we always push as well. And the envelope, it's the least amount, right? Mechanical systems are expensive. The envelope is the least expensive to spend the money at, right? It's the biggest bang for the buck. So spend as much as you can.
Well, and interestingly enough, it's like go big in your attic. I mean, that's cheap insulation. I mean, if it's a raised heel, flat ceiling attic, gabled roof, go fat. Put in a raised heel and go fat on your insulation, and that's where we lose a lot of our heat. Interestingly enough, the walls are super important for a number of reasons. We find that people say, "Oh, our house is drafty and we want a more comfortable house." But the drafts really aren't drafts often. They're convection currents and microclimates in your living room. So when the wall is cold, the air will drop along the wall, whether it's a window and a wall or whatever, drops to the floor and pools at the floor, and now their feet are cold. And it creates this microclimate or circular motion of air, which is often mistaken as a draft. And it's just a little microclimate in your living room.
Yeah, you get that natural convection going on, right? The buoyancy effects going on in there, and you're feeling that just going on, right? And that's important in windows. That's the spacer in a window. I mean, we could go hours onto the thickness. Yeah, exactly. And how that can affect the performance of window, but it's the same concept. Yeah. So I guess you touched one thing that you touched on was the heel of the trust, and I think that's one area where code can actually have a big effect on design that we're not seeing enough of, right? That there's, it's like the code did do some stuff about how high the heel of the truss is, but we still see it today where we go, that we'll be looking at a project and we'll go, hey, if we do an R70 roof, it's going to knock 5 tons off a project. And again, we work on some, extremely
Bigger
large
project.
homes.
Mm-hmm.
So that's a big deal, right? 5 tons can be, and that's a significant amount of money if we're doing a ground source heat pump system. But you go and we start getting into the architecture.
That's 3 holes in the ground.
That's 3 holes in the ground, right? Yeah, exactly. That's another heat pump. I mean, it's $50,000 by the time it's all said and done. Right. And the heel of the truss isn't there to make it happen, right? And we always run into that a lot. It's one of those things that it would be nice to see the code just say you have to have it so you can go up to an R70. And it's just something that the architects have to design around because it's always too late to make that change. So I think that's one area where I think code can have a big impact on that.
For
that
certain.
area. Yeah.
That's a prescriptive concept, but you most certainly, it could, you can have a performance-based code with some prescriptive requirements, in my opinion.
Yeah, I think that would be perfect, right? I mean, that way it gives us the flexibility when we actually get there. So,
right.
So what advice would you give someone just starting to consider building, designing, purchasing a new home?
Purchasing or starting to build a custom home.
Yeah.
What are you purchasing, an existing one or?
Yeah. I mean, when somebody's looking out to set their 5-year plan on a residence, what do you think they should be looking at, whether it's purchasing or building, right? I mean, I know it's 2 different things, but what do you think that people should really take into consideration that they just don't?
Yeah. I'd like to talk about performance, but right now, if you're building, right, it's lead times in supply chain is a miserable situation right now, and hopefully we get our arms around it over the course of the next year. I've heard it's going to be an issue all the way into next year, but that's one of the biggest considerations at this very moment. But beyond that, as far as what I do, it really is considering the 5 concepts of passive house. You can take the approach of passive house and not necessarily go the distance. You don't necessarily have to get certification. While it would be great to have the badge, it's not critical to get certification, but leveraging the concepts of airtightness with vapor open walls, and it's 5 concepts. It's balanced ventilation, good fenestration, high performance fenestration. It's airtightness. It's a continuous thermal envelope, and super insulation. And what's the last one? I'm drawing a blank. I can't remember. But anyway, go ahead.
Did we touch on ventilation? I didn't.
Balanced ventilation was one. Fenestration, airtightness, glazing, ventilation. Anyway, all said and done, the 5 principles are relevant no matter whether you go for a certified passive house or not. They're very relevant and they're important. So it's for building a house that's going to last for a very long time and is going to use less energy. So we have a lot of clients that leverage the concepts, but don't necessarily go the entire distance. So,
yeah, I mean, I a big takeaway, and I know this just from my house as well, that it's like, on the envelope, we went really well on the envelope. We really well on the windows, fairly well on the windows, insulated as best as we could. The comfort of the house definitely increased for a retrofit. And I think the last time we had a HERS done on it, we're down at a HERS 11. We're about net zero on the meter. And I have some duct leakage that we're going to get replaced, and that should bring us to a HERS of 0.
Right.
But so that's kind of where, just back to the envelope, right? Just, even though being a mechanical engineer, definitely we focused a lot just on the envelope and to make that happen. And the square footage is reasonable enough for where we live. So,
yeah. Same with this place. Previous owners were around $2,200 a year. We've gotten it down to around $500 a year.
Yeah.
And but 3.9 kilowatts on the roof. That's not a big solar system, but we've made a lot of improvements in the envelope. High performance windows. We've gone R65 in the attic. Made a lot of great changes. The low hanging fruit, interestingly enough, cut it in half. Cut the bills in half. So easy stuff, inexpensive stuff. Less than $10,000 was spent to get to half the energy use and paid back very quickly.
And your comfort level is through the roof. I mean, that's the other side. How do you put a dollar amount on your comfort level? Right?
Yeah,
you can't. It's an externality that you just can't really put a value to.
The first round of changes were related to the fact that our kids were 1 and 3 when we moved in, and their rooms have, out of the 6 sides of the cube, 4 of them were cold. They're above a garage, they're below an attic, and they have 2 outside walls. So they only have 2 warm walls on each of their bedrooms. And we're like, we want them to sleep through the night. If they kick the blankets off, we want them to be comfortable enough to be able to sleep through the night, not wake us up. It was about us sleeping through the night.
It's a little self-serving that way. I want to sleep.
It was. And, it made a difference. We went, like I said, R65 in the attic. We also blew some insulation above the garage ceiling so that the floors would be warmer in their bedrooms. So yeah, we drilled and filled and went big on the windows. So our 7 windows. Anyway, but all said and done, it made a tremendous difference in their rooms. Yeah. So yeah, but it was about us.
I need to sleep.
Yeah, right.
Sleep's important, let me tell you.
Right. Well, they're 11 and 13 now, so it's been 10 years in this house.
Yeah. So what's an example of a mistake or failure that you experienced in this industry, and what'd you learn from it?
Oh gosh, I keep wondering if I should have offered that consulting service a while back, because I've been asked so many times. But as far as mistakes, we make mistakes periodically on projects from the products that we sell. And it's not necessarily our mistake, because we are very clear with our customers that they have to verify everything, verify, confirm that everything is accurate. And inevitably, there's something that's missed, and those mistakes hurt, because we want to make it such that they can recover reasonably quickly and easily. So we end up bearing some. What's the word I want? We try to help them as much as we can, and generally we do it at no profit. So in the end, it becomes a very expensive thing, because we end up spending a tremendous amount of time helping them with their mistakes.
So is that down to a detail not being done correctly, an installation error, ordering the wrong product for the wrong application?
We've got a customer right now that didn't pay attention to the timber frame and where it lined up with windows. And instead of being at the head, it's 10 inches below. As a result, the timber frame's right in the middle of the window. Essentially, it's right at the top 10 inches of the window. And we're going to try to help him recover as efficiently as we can, but to a large degree, this was his mistake. It was somebody's mistake, the architect, the designer, I don't know. But the timber frame's actually right at the window that they ordered. So this just found out this on Monday. 2 days ago.
So it's just down to those small little detailing errors that come up to play. Yeah.
Yeah, and those are painful. But as far as like other mistakes, there's certain products that I've carried in the past that probably, I've walked away from that were mistakes, and we've got a pretty good set of products now. I think there are some things we'd like to offer in addition to what we have, but there were a few product mistakes that we made, and I don't want to mention those because some of those companies are still in business.
Yeah.
Anyway,
it's tough when you're repping somebody. They're saying they're going to do something. You're putting your faith in them, and they don't come through.
Exactly.
We've had it's specifying engineers. We've specified some products in the past that, look good. And when it actually got out in the field, there was a lot of issues, and people are looking at us and we're looking at the manufacturer. And so, yeah, I've been in the same situation. It's a sticky situation. So,
right. Yeah.
So what is your favorite building and why?
Favorite building and why? I've got a number of case studies that I get a kick out of. I actually do presentations on them. There's an interesting one down in South Denver. It's a house, and it's passive house certified. So, but I get a kick out of what they did in the first couple years. They literally didn't put in a furnace. I think they actually had to get a variance because they weren't going to put in anything for conditioning the house, with the exception of a couple of space heaters. And I'm not kidding. 1 kW space heaters, one on the basement level, which is a fully finished basement, 1,500 square foot footprint, and the upper level, 1,500 square foot main level. And they put 1 kW on each. And Gary and Susan, it's like the fact that they would even consider that is awesome. It's like, and they leverage the ERV, the ventilation system, to kind of move that conditioning around the house. So, they eventually did put in, I think it was a year or 2 years later, a single mini split, because, it's a passive house, but it's actually an active house. You have to open the windows at night to night flush and bring the temperature of the house down. And then you have to close them during the daytime to make sure you don't lose those cooling gains in the summer months. So the mini split was all about cooling more than it was. They didn't want to be so actively managing the house. They just wanted to push the button and cool the house off. But they apparently are still operating without a furnace or any traditional type of heating, with the exception of the mini split again, and maybe a couple of 1 kW space heaters. I love that house. There's another house up in Boulder that I really got a kick out of. It was so well insulated, so airtight, that before they put the furnace in, and it was a geothermal, a one-hole geothermal, 2,400 square feet, and they were able to do one hole because they got enough BTUs out of that single hole. So they didn't have this sophisticated submarine manifold tying all the pipes together. And it just went straight into the geothermal heat pump. But before he put everything in, it was during one of the polar vortexes that we've had in the past. And he was afraid that, because he kept everything from a previous foundation. He basically kept the foundation to save himself a fair amount of money. And he kept a couple of walls, so we could call it a retrofit or a remodel. And it saved him a ton on his permitting. But he went through the polar vortex, and he was so afraid because he did have the pipes already in, the water, and he was afraid they were going to freeze. And so he'd get over there first thing in the morning, 5:30 a.m., and he would check the temperature, and he said that room never got below 51 degrees because it was so airtight, so well insulated, great windows, and no heat. He had a small space heater blowing on those pipes just to make sure, but it never went below 51 degrees. And during the day, it would go up to 64. No furnace. And it's single digits, single digits outside. And he's literally running the house on nothing. A small space heater. It's awesome. So when you put your mind to it, you got the right assemblies, the right envelope assemblies, the right fenestration, an airtight product. You don't need much. There's one house. It's a demonstration way back when, I can't remember, 2012. They literally ran a hairdryer to heat the place overnight when it got cold one day. They ran a 1,500 watt hairdryer.
Yeah, and if you keep it running too long, then you got cooling issues. Then you got to go back to the flushing, right? So that's
right.
Yeah.
Exactly. So I really get a kick out of this approach. It's the the passive house approach. what they're able to achieve is extraordinary. It really is. You can heat a house with the equivalent of a hairdryer. It's not.
That's remarkable, right? And then the energy to offset that's just so minimal. So
exactly. And to go zero after building to passive house standards is easy. You don't need 10 kilowatts on the roof. You probably get away with 5 or 6 and be zero energy. Throw 10 on and you can run your cars as well. Oh, and that's Gary and Susan. They do have 10 kilowatts on the roof, and they have 2 electric cars, a Volt and a Leaf, I believe. And they're zero energy for both their house and their cars. So the Volt, they have to put about 10 gallons in every 3 months. 10 gallons every 3 months.
Just a small amount, right? The beauty is they don't care about gas prices. They don't care about natural gas prices, right? There's resilient right there. So they front loaded all their utility costs, building this beautiful envelope, tight house. And now they don't care about what's going on with that. That's the other thing that people need to realize is
peace of mind is huge.
Peace of mind. You're making an investment today on known factors versus you get out there in the future. Things can fluctuate where you have no control. Control what you can today, and you'll be a lot more resilient. I think that's the other thing that like passive house puts into it, that standard or that type of construction is it just makes it a lot more resilient going forward. So.
I mean, resilient from a different standpoint. You also have the resilience of the envelope because it's designed correctly. So you've got resilience of the durability and longevity of the building itself is resilient in its own way. And then you look at, energy prices and you're basically hedging today's construction costs against tomorrow's operating costs.
Exactly. And again, I mean, there's a return there because you don't know what's going to happen, inflation, everything else. So you're protecting yourself in the future. So
peace of mind.
Peace of mind. So what is your favorite place and why?
Favorite
place to be?
Oh, in general.
Yeah.
Oh, anywhere with the family. It's fun. We do a lot of camping. We really enjoy going out to Utah and the mountains and camping, skiing. We got good kids. They love to do the things we love to do, which is awesome. They're involved in sports and stuff too, which takes our time away. But in general, when we're out camping or skiing, we go up to the mountains quite a bit. I mean, one of our favorite weekends last year is we got one of the sheds. I call it a shed because it's basically a shed at the KOA and Steamboat. And it was a favorite moment of ours because their Wi-Fi was awesome. This shed, however, was not. It was like a 15 by 15 box, and it had a bunk bed on one side and a queen bed on the other. And we all piled on the queen bed and we watched a movie on my computer because their Wi-Fi was tremendous. But that was a great vacation for us. We really enjoyed it. Went skiing the next morning and stayed 2 nights, and we had a really nice time. But that's the simplicity of our family, I guess. It was a fun weekend.
Yeah, it's great. So for someone listening, how would they like to get a hold of you? If they would like to get a hold of you, how do they go about doing that?
Our website is aebuildingsystems.com. Our phone number's on that website. Just go to the contact us. And the contact us page has, a place where you can fill in your information. We'll get back to you as soon as, we can. We are a small company, just essentially 2 of us. Craig, who works with me, you might hear from him as well. But again, my name is Todd Collins, and my email is, you can just get us at info@aebuildingsystems.com. So that'll get us as well.
Perfect. Great. And thanks for participating in the Better Buildings, Better Society podcast. Really appreciate you taking the time and talking with us today.
This is fun stuff. I think it's important to keep sharing the wealth. This information is important. And, the energy, the climate, all those things are incredible impetus and what's the word? It was what drives me. But when it boils down to it, the reasons to go high performance in building new buildings or retrofitting existing ones, there's so many other reasons to do it that make sense, not just that hedging operating costs. There's a lot of reasons to do it. So anyway.
Yeah, exactly. And I think that's an important thing, right? I mean, we touched a little bit on comfort, right? You can't, comfort's such an externality that how do you put a price on comfort? Like when we do radiant floor design, I go, it's going to be more comfortable. How do I put a price to that? It's never going to pay back, but you're going to be a lot more comfortable with radiant heating or cooling technologies.
Yeah.
So you just can't, right? If you want to be extremely comfortable, we're going to make that happen. That's the same thing with the envelopes, same thing with the windows. A resilient building, that's very important, right? If you're looking to have that building stick around plus 60 plus years, go the high performance standard. There's it's tested, it's proven. That's what they're trying to do with the passive house stuff. And then
we should be considering centuries, not decades.
Exactly, right? Because that's going to have a lower impact. The embedded carbon that's in those materials. If you put it up once, it's there for a long time. It's architecturally looks good. There's no reason to tear it down, scrape, and do something else with it. It still should be there for like generations. And then there's the resilient on the energy cost, right? You may be able to charge a car, your house, and everything with no expense to you coming out of pocket on that. So you're agnostic to what's going on in the world. So I think those are the big takeaways for that. So yeah, great.
Amen.
Yep. Well, thanks everybody for listening. You can go to the dma-eng.com to get the latest episodes. Check us out on the blog, LinkedIn, and everywhere else. And so thanks everybody. And thanks Todd for participating.
Thanks, Stephen. Good to see you again.